Becoming a pioneer of artificial intelligence. Building an artificial intelligence, AI, system from scratch can be a complex process that requires a deep understanding of the problem you are trying to solve, the data you have available, and the AI techniques and tools you will use. Here is a general overview of the steps you would take to build an AI system from scratch. Define the problem. Clearly define the problem you want the AI system to solve. Understand the specific task or tasks the AI will need to perform and the desired outcome. Gather and prepare data. Collect and prepare the data that will be used to train and test the AI system. This step includes data cleaning, pre-processing, and feature selection. Choose an AI technique. Select the appropriate AI technique for the problem at hand. This may include techniques such as supervised learning, unsupervised learning, reinforcement learning, or deep learning. Design and implement the model. Design and implement the AI model using the chosen technique. This step may include selecting a neural network architecture, training the model, and fine-tuning the parameters. Test and evaluate the model. Test the model using a validation dataset and evaluate its performance using various metrics. This step will help you understand how well the model is able to solve the problem you defined. Deploy the model. Deploy the AI system in a production environment, such as a server or in the cloud. This step may include integrating the model into an existing system or application. Monitor and improve. Continuously monitor the performance of the AI system and make adjustments as necessary. This may include retraining the model or fine-tuning the parameters. It's worth noting that building an AI system from scratch requires a lot of knowledge and skills in different areas such as statistics, mathematics, programming, and machine learning. It's also important to have access to large and diverse data set and computational resources. There are many different algorithms that can be used for machine learning, and the best algorithm for a particular problem will depend on the specific task, the nature of the data, and the desired outcome. Here are a few popular machine learning algorithms that are commonly used in different applications. Linear regression. Linear regression is a simple algorithm used for predicting a continuous target variable based on one or more independent variables. It is widely used in applications such as stock price prediction, weather forecasting, and sales forecasting. Logistic regression. Logistic regression is similar to linear regression but is used for predicting a binary outcome, such as yes or no. It is widely used in applications such as image classification, text classification, and spam detection. Decision trees. Decision trees are a popular algorithm used for both classification and regression problems. They are simple to understand and interpret, and can handle both numerical and categorical data. Random forests. Random forests are an extension of decision trees that build multiple trees and combine their predictions to improve the overall accuracy. They are widely used in applications such as image classification, text classification, and anomaly detection. Support vector machines, SVMs. SVMs are a powerful algorithm used for both classification and regression problems. They work by finding the hyperplane that maximally separates the different classes in the data. They are widely used in applications such as image classification, text classification, and facial recognition. K-means. K-means is an unsupervised learning algorithm for clustering problems. It works by grouping similar data points together and finding the centroid of each group. It's widely used in applications such as market segmentation, image segmentation, and anomaly detection. Neural networks. Neural networks are a class of algorithms inspired by the structure and function of the human brain. They can be used for a wide range of tasks, including image recognition, natural language processing, and speech recognition. These are just a few examples of the many machine learning algorithms that are available. Other algorithms such as gradient boosting, XGBoost, LightGBM, etc. are also popular and widely used in many applications. The choice of algorithm depends on the problem you are trying to solve, the characteristics of the data, and the desired outcome. There are several ways to come up with a large dataset for the AI you are building, including Public datasets. Many organizations and individuals have made publicly available datasets that can be used for machine learning. Examples include the UCI Machine Learning Repository, Kaggle, and the US government's data.gov. These datasets can be used for a wide range of tasks, including image recognition, natural language processing, and speech recognition. Web scraping. Web scraping is a technique for automatically extracting data from websites. This can be a useful way to gather a large dataset, particularly if the data is not available in a structured format. However, it's important to be aware of any legal and ethical issues related to web scraping. Crowdsourcing. Crowdsourcing is a technique for obtaining data from a large number of people. For example, you can use platforms like Amazon Mechanical Turk, Upwork, and Crowdflower to gather data from people around the world. This can be a useful way to gather a large dataset, but it can be more time-consuming and expensive than other methods. Self-generated data. If you are working on a specific problem, you can generate your own data by collecting it from various sources. For example, if you are working on a problem related to image recognition, you can take pictures of the objects you want to recognize and use them to train your model. Purchase data. You can also buy data from companies that specialize in providing datasets for machine learning. This can be a good option if you need specific data that is not available publicly or through other means. It's worth noting that when it comes to machine learning, having more data is better, but having good quality data is even more important. You should always check the quality of the data, such as completeness, accuracy, consistency and diversity, before using it for your machine learning model.